Hey everybody, welcome to Geometry, Section 9.1, Translations. This Chapter 9 that we're about to embark upon is all about transformations, which you may have had in previous math classes. We're going to be talking specifically about translations, rotations, and reflections. You might have heard that called slide, flip, and turn. But we're going to be talking about that in more detail along with composition of transformations, dilation, and symmetry. So by the end of this lesson, you should be able to translate, which is to shift a point or a shape along a given vector. We're also going to talk about how to use a compass and a ruler in order to translate a point or a shape. Actually, that's what we would be doing normally, but in the height of the pandemic, we are not going to be doing compass and ruler stuff. So everything that you see in your notes about actually drawing with a compass and measuring out how to move these shapes, we are not going to be doing that. Okay. Instead, we're going to stick to just strictly how to do it on a coordinate plane, how to use it with coordinates. All right. So first thing I want to talk about says translate a point or a shape along a given vector. Well, what is a vector? So I looked it up and it says a quantity that has magnitude and direction and that is commonly represented by a directed line segment whose length represents its magnitude and whose orientation in space represents the direction. What the heck does that mean? Okay. All a vector is something with magnitude and direction. Okay. So for instance, if I said, go stand over there, that's pretty vague. I'm not very specific about where I'm sending you. What if I said, move 5 feet over? That's a little bit more specific. I'm telling you a specific distance to move. Okay, so that's a magnitude. That's how big something is. In this case, I'm telling you how big the distance needs to be that I need you to move. However, if I say move 5 feet, I'm not telling you which way. All right, you could move to the left, to the right, front, back. You could even try to jump up 5 feet. All right. But in order to be a vector, it needs to be magnitude and direction. So if I said, move 5 feet to the east, that's very specific. Okay, that's taking you from where you are, you have a direction where to go, and you have a distance, how far to go. So that's what a vector is. So let's see if we can get a visual on a vector. Now, I bet some of you are like, vector, I've heard that word before. Where have I heard that? Oh yeah, from Despicable Me. Wrong kind of vector, okay? Cool name for a villain, but not what we're talking about. So commonly we represent a vector with an arrow. With an arrow, however long the arrow is, that's your magnitude, and whatever direction the arrow is going in is your direction. Okay? So as they used in the definition, the orientation of that arrow represents the direction. For what we're going to be doing in a coordinate plane, we're going to be using component form, which basically tells you how far to move to the left and to the right, which is represented by your x coordinate, and how far to move up and down, which is your y coordinate. Now you can tell it's a vector and not just a regular coordinate because the vector has those pointed things instead of the parentheses. So if you see those little pointy things, pointed little brackets on there, that means it's a vector. So in this case, you would take whatever shape, whatever point that we have, and you'd move it 3 places to the right and then 2 places up. Okay? So that's how we represent a vector for what we're doing in this case. So let's get to the notes and talk about how to do translations on a coordinate grid. Okay, so let's talk about translations. A blank is a transformation where all the points of a figure are moved the same distance in the same direction. So if we're taking something and we're just shifting it, that's called a translation. So let's see if we can spot what a translation is. So let's take a look at question number 1. So if it says, tell whether each transformation appears to be a translation. So do we take that first shape and just slide it over and that makes the second shape? It doesn't look like that at all. It kind of looks like I took this and I flipped it over. So this point flipped over to there. This point flipped over to there. So no, it doesn't look like a slide. It looks like a flip. So I'm going to say no to that one. Number 2, do I take that first shape and just slide it down and that's the second shape? Well, kind of looks like it. Looks like that point shifts to there, that point shifts to there, that point. Yeah, I'd say that does look like a translation. Okay, question number 3. At first glance, some people might say, yeah, it looks like you just slid it over there. But it doesn't quite look right. Kind of like, this point here looks like it just got shifted over. But this point to here, it doesn't look like it got shifted. It looks like it got turned that direction. So I'm going to say no, that is not a translation. It's not a shift. It's more of a turn, okay, more of a rotation. So I'm going to say no to that one. Question number 4. If I take that bottom shape and just shift it, yeah, I'd say so. I'd say that looks like it's a translation. So I'm going to say yes to that. Now, something that just caught my eye, back up here in the first sentence, it says, where all the points of a figure are moving in the same distance and in the same direction. Then in parentheses it says, it's an isometry. I just want to let you know what that word means. Isometry, if you break it down, the prefix iso means same, and metri or meter means measure. So isometry literally means same measure. And what that means is if you do this transformation, it's not going to change the size or the shape of the actual figure. So if you do a translation, you'll still have the exact same figure that you had, just in a different location. So that's what isometry means. It doesn't change the size or the shape of the figure. Let's continue. So question number 5, it says, draw the translation of the triangle along that vector. So what we would normally be doing if we were doing a compass and a ruler is I would teach you guys how to take that shape and how to move it along that vector. So that vector tells us which direction to move it. It also tells us how far to go. So however long that vector is, that's where I'm going to move it. So because we're not using a compass and ruler, we're not going to be doing that stuff, but I just kind of wanted to show you the idea of what it is. I took this one figure and shifted it just down the road a little bit. Okay, now let's deal with what we are going to work with. Here's 2 graphs, and I've went ahead and plotted those points and connected them. So if you want to pause the video now and do that, you can. And welcome back. So it says we're going to translate this triangle with those vertices along the vector 3, -1. So what that means is we're going to take that and we're going to move it 3 spaces to the right and then 1 space down. Okay? Now on the tests and quizzes, it's not enough just to make the graph. They want to know what each individual vertex is. So let me go ahead and write this out here. So if point D is -3, -1, point E is 5, -3, and point F is -2, -2. And it wants us to shift it along the vector 3, -1. So what that means is I'm going to add 3 to every x coordinate and subtract 1 from every y coordinate. So when I do that to point D, that makes, there we go. So when I do that to point D, that makes point D prime. Basically, it means it's a point that was created directly off of point D. So if I add 3 to the x, that puts me at 0. And I subtract 1 from the y, that puts me at -2. And then we just do the same thing for points E and F. So E prime, if I add 3 and then subtract 1, And then f prime, if I add 3 to negative 2, that gives me a positive 1. And then subtract 1, that will give me a negative 3. And then all I have to do is plot those points. So 0, negative 2, 8, negative 4, and 1, negative 3. And then I will connect those points. And hopefully you can see it's the exact same shape, just shifted a little bit. Okay, let's do the same thing over here for number 7. So it says translate along the vector negative 3, negative 3. So that means I'm going to subtract 3 from the x and subtract 3 from the y. So if I were to do that for r, that would make r prime negative 1. And then subtract 3 from the y will give me 2. S prime subtract 3 gives me negative 2. Subtract 3 from the negative 1 gives me negative 4. T prime sounds like someone's rap name. T prime. So negative 1 or 1 minus 3 is negative 2. Wait a second. I messed up, didn't I? Let's back that on up. S is 0, 2. So that would be, I did T where S should be. So let me erase that real quick. So S prime would be 0 minus 3 and 2 minus 3. And lastly, U prime, 3 minus 3, and then 1 minus 3. All right, let's see how this looks. So negative 1, and then up 2, negative 3, and down 1, negative 2, and then down 4, and then 0, negative 2. Okay, so at first glance, it looks like the same shape. Let's go ahead and connect it. And there we go. It looks like the exact same shape, just shifted down a little bit. Matter of fact, shifted 3 places to the left and 3 places down. Okay, so that's what we're going to be covering. And some people might just look at this graph and say, well, can't I just look at the graph and then take that vertex and move it back 3 and down 3 and plot it? You can, and that's definitely a good way to double check your work. However, on the test and quiz, it's going to be looking for, can you write out the coordinates of the vertices? So it's good to do both. If you guys have any questions, please feel free to email me. Feel free to ask in class or on a Zoom meeting. And hopefully this chapter is not going to be too bad. It's a nice little chapter to put in between Thanksgiving and Christmas. And hopefully you guys will do well. I will see you guys real soon. Take care.